you want me to gather them down?
Yeah, I think so. I think Kate's just got past the headphones, so I'll just get it.
Now that's a magnet, and wherever you place that magnet on the rock, that's where it stays.
Oh.
You just give it a try. Now when we talk about these magnetic anomalies, we're not talking about a little piece of rock like that. We're talking millions and millions of tons of this, and that's how they locate them today and find these big mines that are hundreds of feet People at the back just come up a bit. This ore body was located approximately 800 feet from the surface when we first located it. Where they found that ore body, and I'd been prospecting the best part of my life, and I would never have looked there for mineral. It was just a red moulder soil, just in the middle of a moulder scrub. Yet 800 feet below it was this big gigantic ore body. After they discovered that ore body, they spent at least 18 months drilling it before they done anything else. They knew the size of it, the shape of it, how much mineral it had in it. They even made the scale model of it before they seen it, how they planned they were going to mine it. They planned that they put their main shaft down where it would be off the centre of the ore body itself. They'd actually mine it in 15 levels with one loading station below the 15 level. They'd have an ore pass cut in the rock from level to level going down to the loading station. So they could be mining 3 or 4 levels at a time. The ore would be emptied into the ore pass where it would drop down to the loading station and then hauled up to the surface in their skips to be milled. To overcome the problems of the dust that was going to be created by these operations, and also for the first time on this field here, they intended to use diesel operated front end loaders underground to get rid of the carbon monoxide fumes that were going to be created. They put in 2 ventilation shafts. This one was situated directly over the top of the ore pass, and on the surface side of that shaft was this big gigantic fan. They call them an Eriks fan. And an Eriks fan is designed to act very much like a vacuum cleaner, and it sucks the dust and the carbon monoxide fumes out from underground. The second one is pumping fresh air in behind where that one's taking it out from. So it's continuously getting replaced with fresh air all the time. There's also fresh air coming into your mine on your main shaft with your skips and your cages working up and down all day hauling ore out. That's like a big pump pushing air into your mine. They worked out how many, the loading station actually was situated approximately 2,000 feet from the surface. I've got to talk in feet because they were the language I grew up in and I never bothered converting them into any other measurements. But it was approximately 2,000 feet from the surface. But the shaft itself extended another 200 feet below that. They worked out how much water to expect that was going to be coming into the mine from the underground water supply. And they worked it out that if they had a 200-foot sump, as they called it, they'd have a pump station on the 15 level with pipes running down to the bottom of their sump. But if they did lose power at their pump station, it'd give them so many hours to get that power back on again before the water level rose high enough and they flooded their pump station. The skips only the cage only goes as far as the loading station, but there's a ladder that comes down your main shaft also, and that ladder goes all the way down to the bottom of your sump. It goes to the bottom of the sump for 2 purposes. One, it's there for maintenance. If ever you've got to go down there for maintenance purposes. It's mainly there for safety. Because if anybody working on that ladder was to slip and fall down into the sump, there is a way of getting out. It wouldn't be just floundering around in water until he drowns. Because at times men are actually working on that ladder, and that ladder's vertical for 2,000 feet. Because beside that ladder, they actually bolt rocks together. You'll be seeing them all through the mine as you go through there. You put different sized plates at the back to support the walls and the roof. Now to fit them, you drill, that's sound effects you're hearing. To fit them, you drill a hole where you want to place them, the length of the bolt at that smaller diameter, what you see the end there is, and they're forced right in the full length with compressed air. And because they're spring steel, as they go in they close up and then they just lock there and stay there. And they actually support everything. They never had them in my day, they've only come out in the last few years. A very simple arrangement and very, very effective. I only wish I would have thought of it, I would have been a rich man today. Very simple, very effective. I better tell you a little bit about this mine we're going to have a look at. It was dug by, it won't hurt you, it's a little, they call them a bent, they're the smallest bats in Australia. So they're got a flat nose, but they're not vampires. But this mine was dug by a mining company that came here to Tennant Creek, a company called Normby Mining. Now when Normby came onto the Tennant Creek goldfields, they were just a medium-sized gold producer. But for the amount of gold they obtained, two dishes, large one and a small one. In the large dish, they pour water. You put the crushed up sample in the small dish and you wash it, looking for a speck of gold. That's all he was looking for. And if he could see a speck in it, he'd tell his mate it's still there. His mate would go down further. He'd go down until he got to the bottom. Then he'd follow it in from where it was leaching from. Now they're not a very old light, they were still being used in my day. We used to use them in stock camps in my day. Now you put a lump of carbide in the bottom section here, and the top here you fill with water. You turn on that valve and that allows the water to drip down onto the carbide. And when water drips onto carbide, it creates a settling gas. You set fire to the burner and that was your light. We call this a kipple, because the kipple's used for hauling the ore and the rocks out from underground. Now the kipples come in all different sizes, but regardless of what size they were manufactured by the blacksmith who was in the area at the time. They have to be made out of heavy material like you see here, because this one, full of heavy ore and rocks, would weigh very close to 5 tonne. And the last thing you want when it's being hauled up to the surface is the handle to pull out of the lugs or the bottom to drop out of it and the rocks come down on top of you. Now they would have had to have a winch to haul one this size to the surface. So above the shaft they'd have a tripod made out of 3 lengths of bore casing with a snatch block in the centre of it. And a steel cable would run from the handle of their kipple up through the block and over to their winch. Going across the top of the shaft, they'd have a railway line going across, and that line would be slightly wider than the kipple, so that when the kipple was hauled up, it would be hauled up and held above the line, and then they could push a trolley underneath it, lower it down to the trolley, and then wheel it out to where they wanted to dump it. We go on a little bit further and we'll actually... And he has a length, he's digging the hole to put in his explosives. And to dig the hose, he's using what they call the hammer and tap. That's a handheld drill and a hammer. They have a length of rope running from the surface down there with them all the time. That's called their lifeline. And on the surface, that rope is connected to a signal. And that's how he keeps in touch with his mate on the surface. So many pulls on that line will mean different things. They also have a length of hose running from the surface down there with them, a length of garden hose. Now on the surface, that hose is connected to a set of bellows. And when he drills that hole deep enough and he wants to clean the dirt out of it to put in his explosives, he pushes the hose into the hole that he signals his mate he requires air. And his mate pumps air down through the hose and blows the dirt out of the hole to clean it out. Back onto the surface, and both him and his mate take turns pumping air down through the hose, and they blow that dust out so he can go back in and go and work. When he finds the ore body, and he finds that it is big enough and rich enough to develop into a mine, he puts in a second shaft. He rises up from the ore body to the surface with a second shaft, and then he has a flow of air coming down one and going out the other. And that keeps the dust moving out of his mine all the time. And actually, once you get that second shaft in the summertime here, it's actually cooler working underground than it is on the surface. But until you get that second shaft in, going in little holes like that, it's very, very hot and humid. In fact, if he was twice that distance in, of a morning when he comes down to start work, he'd have the hose with him and his mate would be pumping air all the time while he's going in, because it's quite possible that at the end there, the oxygen settles overnight and there's no oxygen. And he'd just black out, and of course being by himself, that'd be the end of him. But once you start working, that keeps the air moving and it's all right after you start moving. But if a holes with the putting your explosive, you use the hammer and tap, you give them a hit and a turn, hit and a turn. And it was a very hard and slow process. To blow a 6-foot face would require at least 4 holes. One at the top, another one about here, another one about here, and one on the floor. When they were using the hammer and tap, they only went in 18 inches. Into each one of those holes, he'd poke a full stick of gelignite. Now, the electric detonators weren't used on this field until after the Second World War. They were the burning fuses they were using. So into each stick of gelignite was inserted a detonator with a fuse attached to it. The ends of those 4 fuses, he would have bunched them together and tied them together so he could actually light the 4 of them at once. They were also cut at different lengths so they go off at different times, because after he got them burning and made his way back onto the surface, he'd count them going off. And when the 4 of them had gone off, it was safe enough to come back again, 18 inches out from there. Then we go over here, and that's it, and another one over there, another there. And what we do, we put a circle around the centre that's about 18 inches out and about 18 inches apart from each other. Then we go about another 18 inches out from that and do the same thing again. And we put another circle around the first circle the same way. And what we do, we keep putting circles around circles until we get the size of the ring that we want to blow. And then we bring our machine in and we drill all those holes the depth that we want to blow it at. And after we drill all the holes, we move our machine out the way, and then we get our detonators and our primer. The primer is the half a stick of gelignite you're going to insert your detonator in. Now, when you mine in and you get your electric detonators, the fuses are already attached to them when you get them. So first of all, we get the instantaneous detonator, the one that's going to go off immediately. We insert it into its primer and we push it right up into the end of the centre hole. And we bring its fuse out to here. And then we get the first lot of delayed detonators that's going to go off, prime them up and feed them in the first circle around the centre and bring their fuses out to here. And then we get the next lot of delayed detonators that's going to go off, prime them and feed them in the circle around the first circle and so forth until all the holes are primed. And then we get our explosives. And we put the amount of explosives into each hole we want to put into, and we plug them up with waddy, plug those holes up tight. And all our fuses are brought out to here, and we have a firing line then running from where we're going to fire from down to this point here. And we connect all those fuses to that one firing line. And we go back and we send an electric charge down through the firing line. And we get a series of explosions all close together. Boom, 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 they go. The first one is your instantaneous detonator in the centre, exploding the charges in the centre, and that blows a hole in the centre. Then the first lot of delayed detonators go off after that, and they take the least resistance. They blow into that hole. And the next lot blow into them, and the next into them, and so forth. And when you clean all your broken rock out, that's the results you got. Your walls are still solid, your roof's solid, and your floor's solid, because you blew everything into the centre. Fairly simple. Gone a bit further and underground. It was being used in my time when I started at Pico, but I was always frightened of it. They call it a bogger. And the bogger was the first mechanical loader to be introduced onto this field. Before the bogger was introduced, those trucks were actually filled by hand and then pushed by hand by two men. At Pico, to speed up operations, they introduced a bogger to fill them, and they had little electric locos that used to pull 7 or 8 of those trucks fully loaded at a time. I used to drive a little loco, that was my limit. I was frightened of this machine. I'd operate it, but not flat out. When you're on contract, paid by a tonne, and you've got to work flat out on it. And I was always too frightened to do fast. But the bogger could only pick the ore up off the line. But there's a few dangerous points about it I better show you first. After you pick the ore up and you tip it back into the truck behind you, and it's going back overhead, of course there's about a tonne of rock in there, and it's top heavy. And if your line wasn't real rigid, it was quite possible to tip the bogger one way or the other. So you had to make sure you had a real rigid line all the time. And also this arm that goes back and carries the bucket, you see how close it is to the body of the machine there? You operate the machine by standing here. If you left your hand there, when this comes back, it's gone. Cut your fingers off to there. So you've always got to keep your hands out here onto your machines. And you'll probably bring a floodlight in and leave out of your way, give you a bit of background light, but everything you do in working with the cut man. And if a big rock was jammed in there and you didn't know, and when you go to tip it and it doesn't come out, a sudden jar of it lifts these off the line. Then you've got to get a crowbar and put it back on again. They were a very frightening machine, those machines. I'll give you a demonstration. But in a confined space like this, it might be advisable to put the earmuffs on. I'll leave that to the fitter, I think. Just a moment, I think I turned the air off on my road thing. And they were what they were using pre-war fuses, and they were filled with black powder, I believe, and they had a tar wrapping around them to keep them waterproof. My father told me when you ordered a roll of fuse cable, you ordered how many feet per minute you wanted it to burn at. And the first thing you did when you got your new roll of cable, you cut 3 foot off, set fire to it, timed it, and make sure it was burning at that speed, so you knew what length to length of fuses. They'd done away with using gelignite as the main explosive when I started work in 1963 at Pico. They were using what they call ANFO, ammonia nitrate fuel oil, or other words, fertiliser mixed with dieseline. The fertiliser is ammonia nitrate, and that's it. It's ordinary garden fertiliser. It's in a prill form so it doesn't pack up when you mix the dieseline in it. Now Pico had 7 mines working in the district, but all their explosives were actually mixed at Pico and then sent out to the different mines as they ordered them. The shed where they mixed the ANFO shed they called it, was situated about 2 miles from the main works area. That was a galvanised iron shed, but every joint on that shed had an earth wire attached to it. I've never made the same way. They're made on an angle off the drive like you see here, so that if you're in here sheltering and there was an explosion down there, the blast will go past and it's quite safe while you're in the crib room. Now when I worked for the mining companies, they used to work 3 8-hour shifts underground. The day shift, the afternoon shift and the night shift. I believe now most big mining companies work 2 12-hour shifts because they're using bigger machinery, getting bigger tonnage away. They work so many shifts on and so many shifts off. But we used to, 8 hours we used to work. We done all our explosions while we were underground. These days, because of the big explosions, everybody's got to go to the surface. But when you set your charges up, you're sheltered in the crib room. The firing was always done from the crib room. Where I was telling you down there at the face, they had a firing line running down there. Well, the firing line would have been run from the crib room down to there. Now, the end that's left back here, it's very important when you're running out the firing line. The end that's left back here, those 2 bare wires on the end are twisted together, short-circuited, so that no static electricity could possibly get into that line. If it did, and you connect them up to a detonator, it could blow up while you were doing that. So it's very important that that's short-circuited. Now the firing's done on the last smoko of the shift. On a day shift, that'll be 3 o'clock in the afternoon. So at 3 o'clock in the afternoon, everybody's got to be here in the crib room. And the shift boss comes along and he checks that everybody that come onto this level is now here in the crib room. When he's satisfied they're all here, he then sounds a whistle to say he's about to fire the face. He then opens up that cupboard, and out of the cupboard he takes this little black box that's been locked up. We call that a Beethoven. It's probably got a different name, but we call it. I've never heard of it anything else. It's actually a dynamo and a capacitor. The dynamo generates electricity and the capacitor stores it. And it generates and stores 15,000 volts. Very similar to the coil on your motor car for your spark plugs. Thousands of volts but no amps. He then gets the firing line, undoes the short circuit, and he connects the 2 bare wires to those terminals. Then he winds up his Beethoven. The faster you turn the dynamo, the more it generates. And when 15,000 volts is reached, that light lights up on the top. You see it? See that light lighting up on the top? Now we just hold that over there like that, hold onto the cable. Touch those from here. You press that button. Yeah, press it in hard. Send the charge down there, blow the face, and after a while one of the miners gets up and turns on a fan and starts the air circulating and get rid of the dust. And at 4 o'clock they pick up their lunchbox and walk down to the plat. The cage comes down, the afternoon shift gets out, they get into the cage and go. In touch with the winder driver, the man that's operating the winch is calling this, the same as that old-time prospector used to keep in touch with his mate with his lifeline. They still do it today, but they call it the knocker line. And help with electricity, it sends signals to every plat and to every winder room. So when he wants to tell that winder driver to stop, you get one ring like that, and that means hold it, don't move it till you get the next signal. Now, if they were bringing machinery down underground, he'd hold that when the machinery just got to the bottom here. When they got the winch onto it and they wanted to lower it out, he'd go, and that means bring it slowly down and then get it down. And when he'd got it right, stop it again and wait. Now, every plat has a standard start signal sign. and also in the Windaroo. And those signals are international. Every country in the world that has got underground mines all use the same signals. This is an ore pass. If you remember the scale model I showed you at Warrego, they had an ore pass running from level to level down to a loading station. An ore pass is a pass cut in solid rock, and it goes down from level to level. So when they're mining on a level up above, they'd empty the ore into a grizzly like that, and they'd go down into an ore pass, and it would come down here to where the loading station would be underneath here. The ore's held back with that chain gate until you want to fill your loading station. And when you want to fill the loading station, you open the chain gate and allow the ore to come down. When you get the loading station full, close it up again. The loading station's cut into solid rock, and it's only it's made to hold only as much ore as what your skip will. So that when you fill your loading station, you can't put too much ore in it, you can't overflow it. It's very much like a jet engine, so you're wearing earmuffs all the time when you're working underground. This was the first long hole core drill to go underground. They had a diamond bit on the end of them. I was just looking for the diamond bit, but it was here the last time I came here, but it's not here now. This came onto the field in the mid-1950s. Before it actually come onto the field, the only way they had to estimate the life of the mine was to go in, like you've seen that old prospector, in little holes to find out how far the ore body ran in different directions. But when this came down, they'd set this machine up and drill in any distance they like. They just put more lengths of rods on, and they can go in 100 feet, 200 feet, whatever they wanted. And the cores are taken out, they cut cores, and the cores are put into trays where they're sent up to the surface, and they're assayed by the geologist. But this particular one, if I could find the bit, I showed you, but the bit's not here, unfortunately. I don't realise that it came into